Good morning, students. I am Atinder Pal Singh, Senior Lecturer, Government Polytechnic College, Madra. So, today we will be taking up the topic of fuel supply and ignition system in petrol engines, particularly in spark ignition engines. More stress will be laid on fuel supply in petrol engines, and if the time will permit, then we will discuss the ignition system also. So, the fuel supply system, fuel is the main energy source. It is the chemical energy of the fuel which is converted into mechanical energy by an engine. So, how it is done, you have already gone through that. There are 4 strokes: suction, compression, and then ignition, and then power stroke and exhaust. So, these are the 4 strokes. So, where in case of petrol engine, the fuel and air mixture is supplied and is burnt inside the engine, which gives us the power strokes after the compression stroke. So, first of all, we will go through a typical spark ignition fuel system layout, which is simplified for you. So, what are the major components? So, first one is the fuel tank. So, fuel tank means where we store the fuel. From the fuel tank, the fuel is supplied by a fuel pump to the air filter through the fuel filters to the carburetor. So, what is carburetor? Carburetor is an instrument which mixes the air and fuel in proper ratio and supplies it to the inlet manifold of the engine, and from the inlet manifold it goes to the combustion chamber, and whatever the fuel is left, it is sent back to the fuel not used is returned to the fuel tank. So, the main we will be concentrating on the carburetor. So, carburetor is, what is carburetor? Carburetor is an instrument which mixes the air with the fuel in a proper ratio outside the engine. So, in mixing, it does not mean that we mix the liquid fuel. Another function which is most important is atomizing and vaporizing of the fuel in the carburetor. So, this is done by injecting the fuel into the air coming through the venturi, that we will be discussing after we know the construction. So, first of all, what is carburation? In petrol engine, the air and fuel is mixed outside the engine and partly evaporated mixture is supplied to the engine, as I have already told you. So, the fuels such as petrol, benzol, alcohol are used in spark ignition engines, that are because they can be vaporized very easily and mixed with the air to create a combustible mixture. Whereas the oil fuels like diesel, they are heavier fuels, they are used in compression engines, they cannot be vaporized and cannot be burnt, cannot be supplied mixed with the air. So, during the suction, the air is sucked as the vacuum is created. This is air is sucked into the carburetor, not into the engine. Not during the suction stroke, the air is not sucked into the engine. So, now there is one more component in between the air filter and the petrol engine. So, during the suction stroke, the air from the atmosphere is sucked into the carburetor. So, the fuel is injected in the air from the carburetor. So, the fuel now is injected into the air by the carburetor and mixture is then supplied to the engine cylinder. It is desirable to have a complete vaporized mixture, to have complete combustion, of the fuel, to use its whole chemical energy. We must completely vaporize the mixture before we supply it to the engine cylinder, but some of the larger droplets may reach. Atomization may not be proper. So, then some droplets may reach the cylinder in form of liquid and then they are mixed and vaporized during the compression stroke. So, when they are in the at the end of the suction stroke, when the piston is at bottom dead center position, the compression stroke will start. It will agitate the air and the fuel mixture there, then those droplets, if any, they will be further broken off. So, but the time available for atomization, mixing and vaporization is very small. Very small means 0.02 seconds when an engine is running at 3000 rpm. So, when an engine is running at 3000 rpm, what is the time for all this process to take place is 0.02 seconds. So, to design an instrument, to design an machine which will supply air fuel mixture in proper ratio atomized, the time available is 0.02 seconds. So, the temperature is one of the main factors which accelerates the vaporization, but it will reduce the power output due to the reduction of mass flow. As the fuel is heated up, its mass flow will reduce and that will reduce the power output. So, we have to take care of this. The design of carburetor is difficult and complicated as the requirement of the engine. Requirement of the engine is not running at a constant speed. It starts from 0 rpm, then it reaches to, it can reach up to 3000 rpm, 5000 rpm as the design is, and it may not continue to run at one constant speed. There may be variable speeds, variable loads. So, depending upon the ratio, the air fuel ratio, air mass of air and mass of fuel ratio will be from 1:1 to 15 or 19:1 under different conditions. The air fuel ratio may be from 1:1 and up to 19:1, and the carburetor has the responsibility to supply the air fuel ratio, the air fuel mixture with proper ratio at every conditions depending upon the type of load, the type of running conditions that we will be discussing later on. So, what is carburetor? We have so far learnt. Carburetor is basically a device for mixing air and fuel and atomizing it in the correct amounts for efficient combustion. So, atomized fuel, it should be a carburetor is basically a device for mixing air and atomized fuel in the correct amounts for efficient combustion. The combustion should be efficient, only then we will be getting the maximum of the energy. The carburetor, where it is placed in the engine, the carburetor bolts to the engine intake manifold. The air cleaner fits over the top of the carburetor to trap the dust and dirt. So, after the air filter there is carburetor and then inlet manifold and then the engine is there. So, what is carburation? So far I have already given you some hints. So, what is here I try to define what is carburation. The process of formation of combustible fuel air mixture by mixing the proper amount of fuel with air before it is admitted into the engine. This you can take the note also. What is carburation? The process of formation of combustible fuel air mixture by mixing the proper amount of fuel with air before it is admitted into the engine. It is the process of preparing air fuel mixture in SI engine outside the engine cylinder. The air fuel mixture is prepared outside the engine cylinder. The device used for this purpose is known as carburetor. The carburetor comes from the word car and burette, because carburetor meters the appropriate quantity of liquid fuel like burette in the chemistry labs and mix it with the air before sending the mixture into the engine cylinder. So, carburetor means metered fuel air into the engine. So, what is atomization? So, I was using this word earlier on. So, here I want to define what is atomization. Atomization is the process of breaking up a liquid into tiny particles or droplets to atomic, atom, it is taken from atom. So, to the atomic size or molecular size. So, the fuel is supplied in the form of liquid. So if we try to burn the liquid in the engine, it will not be burning efficiently. So what we have to do is increase its surface area so that it can come into contact with the air, the oxygen in the air, and burn completely to give maximum energy stored in it, all the energy stored in it. Our target is to burn each and every atom of the fuel supplied to us to get the maximum energy. So what is the process of atomization then? Atomization is the process of breaking up of liquid into tiny particles or droplets. When a liquid is atomized, the droplets are exposed individually to the air. Every tiny particle will be surrounded by the air. The surface area will increase tremendously. For this reason, atomization greatly increases evaporation by increasing the exposed surface area of the liquid. So what will happen? It will readily evaporate. So here in this diagram we can see what is atomization. Like through a pump, liquid is supplied and which is broken into very small, liquid broken into very tiny particles. This is a simple example of this. So air is supplied from there and then liquid is stored in the jar. Now when we blow it, the air will move at a very high velocity, causing depression of pressure on that pipe which is connecting it to the fluid in the bottle, and the fuel will gush out and mix with the air and is broken into smaller particles. So this is atomization. This is very important. We must clearly understand that the fuel is mixed with the air in atomized form. If it is not in atomized form, the combustion will improper and the fuel will go unburnt or semi-burnt into the atmosphere. We will lose in the energy sector also, and then it will cause pollution. It will cause the unburnt carbon will result in carbon monoxide and sulfur in sulfur oxide. So these are very poisonous. So what is air fuel ratio? Now we have learned that what is supplied to the engine is air plus atomized fuel. So now what is the air fuel ratio? What is how much air and how much fuel is to be mixed together to form a efficient combustible mixture is called air fuel ratio. The ratio with which air is mixed with the fuel for the purpose of combustion. So what is air fuel ratio? The ratio with which what is the mass of air and what is the fuel supplied, what is the mass of fuel that are to be mixed for the purpose of combustion is called air fuel ratio. So there are basically broadly three different type of mixtures based on air fuel ratio. One is chemically correct, another is rich mixture, another is lean mixture. Chemically correct mixture, rich mixture and lean mixture. Chemically correct mixture, by name it suggests that the amount of fuel that is mixed with the air are in balance with each other. The amount of oxygen available in the air and the amount of reactive fuel will combine and form a flame, form a totally combustible material. Then this is called a chemical correct mixture. And then a rich mixture, where rich means the fuel is more as compared to the air. So this is rich mixture. So it will ensure that there is more combustion in the engine. So that we will discuss later on. Lean mixture, where air is more. So chemically correct mixture, it is the one in which there is just enough air for complete combustion of the fuel. So to burn 1 kg of octane C8H18, this is called an octane. So to burn 1 kg of octane completely, 15.12 kg of air is required. So that means if we are making a mixture which is 15.2 kg of air and 1 kg of fuel or its proportions, then it is chemically correct mixture. The whole air available and the fuel are in chemical equilibrium to burn, to cause an oxidation reaction. What is lean mixture and rich mixture? A mixture that contains more air than correct ratio is a lean mixture. More than 15.2 to 9, 10, 20 is to 1. These up to this the mixture will, the flame will sustain and it is a good combustible mixture. This is called lean mixture. Beyond this the flame will not sustain and that is not a useful air fuel ratio. A mixture that contains less air than correct ratio is called rich mixture. 10 is to 1, 12 is to 1. Less than this, again the air will not be there to burn the petrol and the flame will not propagate, it will extinguish. It will bujh jayegi. It will extinguish if the air is less than this, in the ratio less than 10 is to 1. So, we have to work in these ranges in between chemically correct mixture, lean mixture and rich mixture. So, the question is which type of mixture we would like to supply our engine for the most of the time? Yeah, what do you think? The answer is lean mixture. Naturally, lesser amount of fuel giving us a good energy and good fuel economy. So, we will be saving on the part of fuel costs. So, our tendency will be to run the engine with the lean mixture and or at the most chemically correct mixture and not with the rich mixture, because the fuel will not burn completely when it is rich, because the oxygen is not available. So, it will not burn completely and fuel will go waste, but it is required at some times when we require high power, when we are climbing a hill, when our vehicle is loaded, when we are to start an engine, then it is required that we supply a rich mixture to ensure that the power developed is on the higher side. There is no leniency in that. So, what are the basic carburetor parts? So, one is carburetor, air horn or choke, throttle valve, venturimeter, main discharge tube and float chamber. These are the main 6 parts. So, we will discuss them one by one. I first show you how it looks like. Carburetor fitted in your cars or motorcycles look like this. This is fitted just with the air filter, and from the below it is fitted with the pipe which is coming from the engine, that is called inlet manifold. So, this is how it basically actually looks like. But now we will discuss what is this. So, this is the working of a carburetor, a simple carburetor. So, what is the outer side? There is a barrel which is called the body of the carburetor. From in this, here I would like to show you, this is the main part, this is the barrel, this one, this is the barrel which is getting fuel supply from a fuel tank or a float chamber which is connected to the fuel tank, and this is the choke which normally remains open, and the most important area is here. This is venturi, the restriction caused in this is venturi. So, this is here we will learn how the fuel is mixed. So, now when the suction is there, throttle valve, this is throttle valve, this passage is open. Let us first assume that this passage is completely open and a suction stroke has started. So, the suction stroke means the increase in volume of the cylinder and which will cause reduction in pressure over there, which is transmitted here. So, in this area, in this whole area, in this pipeline, the pressure will drop, and from the outside through the filters the air will rush into this pipe. So, now here the velocity will be less, but as it enters the venturimeter, the area is restricted. What will happen? The velocity of air, because it has to maintain the uniform flow. So, the A1 V1 is equal to A2 V2. So, now A2 is reduced, so V2 will increase, the velocity will increase, causing the depression in pressure. So, here the depression in pressure is there. So, here this is a line, oh shit. This is the pipe, this pipe is connected to the float chamber. This is float chamber which maintains the level to be supplied in the level of the fuel to be supplied to the carburetor. So, from here the due to the drop of pressure here it is connected to the atmospheric air. The atmospheric air will press it down and the fuel will rush from here, the liquid, here it is liquid. So, it will rush and this is the constricted area which is vertically upward and it will supply the fuel in the form of a jet like this. The jet will be there. So, the jet moving upward and the air moving downward will mix. They will strike with a velocity which is the sum of the two velocities because they are in the opposite sides, and the air will break, air will atomize the fuel. It will break it into smaller and smaller atomized particles and proper mixing will take place and keep on taking place in this whole area, and up to this area the complete mixing will be there and it is supplied to the engine. So, again this is the float chamber which is connected to the atmosphere from here. So, the fuel, the air during the suction enters here due to the depression of pressure and the velocity increases in the venturi area where the main jet, this is main jet is there. So, which throws the fuel in the opposite direction to the direction of the air coming. They strike with each other and atomize the fuel which gets mixed up with the air and is supplied to the engine. So, this is the basic carburation process. If we are able to understand this thing, then nothing is more than this. So, what we are doing is from float chamber liquid fuel flowing here due to the depression of pressure striking with the air and then it is there. So, one more important is throttle valve. So, throttle valve is a disc shaped valve that controls the air flow through the air horn. Air horn is your choke. When the throttle valve is controlled, this is the closed position 80%, the flow of air and fuel into the engine. When opened, the air flow, fuel flow and the engine power increase. When it is closed, this area will be closed and there will be restricted supply of air and fuel from here. If it is totally controlled, then there will be no supply from this area. So, as we open the throttle valve, more air and fuel mixture will enter into the engine. So, now what are the type of mixtures that are required for different running conditions of the engine? So, what we have to do is we have to start an engine. So, air fuel ratio for starting. So, very rich mixture is required. Engine is cooled and we want to start it. So, very rich mixture is required during starting because during starting very small amount of fuel is vaporized and rest of it stay in the liquid state so as to give an ignitable mixture. So, initially when the engine is cooled, when we are starting an engine, then a rich air mixture, fuel air mixture is required. Then air fuel ratio for idling. So, what is idling? Idling means when we are doing nothing. So, when the engine is not doing anything, that is called idling. So, like we have started the engine and we have not yet put the load on it. Load means if we are sitting in a car, we have not released the clutch pedal and put it in the gear. It is not moving, but it is standing still. So, in idling, engine demands a rich mixture. Why? Because when the engine was running, some of the unburnt gases will remain in the clearance volume. So, they will mix with the charge coming. So, now the engine is not running and throttle valve is closed. So, how to burn it? So, for that we require rich mixture in the idling stage. The throttle is gradually opened during idling. When we start, now we have put it into the gear and we start moving, then we will gradually open the throttle and we will start putting load on it. So, here it is written there. Later when the piston moves downwards, the gases along with the fresh charge go into the cylinder. A rich mixture must be supplied during the idling to counteract the tendency of dilution and to get an ignitable mixture. So, what type of air fuel mixture is required during idling is a rich air mixture. Why? Because it has to counteract the effect of dilution basically. So, air fuel ratio for medium load when we are running the car at a normal speed 40, 50, 60, 70 kilometers per hour. Most of the time we are running in this speed, at this speed the engine is running in a medium load condition, therefore, it is desirable that the running should be most economical in this condition. So, when economy comes, what type of mixture I had told you earlier on, what type of mixture is required, that is lean mixture. So, engine has low fuel consumption at medium load, but and we will get the best economy. For multi-cylinder engine, slightly more fuel is required due to maldistribution of the fuel. So, air fuel ratio for maximum power range. When maximum power is required, when we are going upstream, upside a hill or the car or truck is loaded, then maximum power is required. So, what type of air fuel you suggest, ratio you suggest? It is rich mixture, because economy is not a consideration. The thing is that the engine should not stop, it should be a highly ignitable mixture. Then air fuel ratio for acceleration, when we are pressing, during the pressing of our accelerator, when we are pressing our accelerator. So, when it is required, when we are overtaking or increasing the speed. So, what is the requirement? A rich mixture again, because we have to create extra power there. So, a rich mixture is required for acceleration. So, 5 types: starting, idling, normal running, then power, and then acceleration. 5 type of fuel air ratios have to be maintained by an carburetor. So, these are the functions of the carburetor then, to provide air fuel mixture for all operating conditions as we have discussed earlier, to maintain a small reserve of pool petrol under constant load, to vaporize the liquid fuel by means of engine, to provide rich mixture for starting and power and during acceleration. So, these are the main functions of our carburetor. So, by it now we have learnt what is carburation, what is a carburetor, what it does and how it does that. Some portion of this we have learned that during normal running, when the throttle is open at a constant speed, the air will flow through the venturi and it the fuel supplied will from the main jet will mix with it, atomize, get atomized, mixed and is supplied to the engine. So, then this is the graph which shows from 0 to 100 throttle openings, 0 to 100% throttle opening. So, 0 to 30 approximately is idling range. So, here initially we supply very rich mixture and it goes on leaning down, and then from 30% to 70% opening, it is the cruising range or regular running range. Here we get the best economy. Here we supply lean mixture. Then power range or acceleration range is there from 70% opening to 100% opening. So, C, D curve is shown there and C dash, D dash for multi-cylinder. So, here then again as we open more and more throttle, more and more rich mixture will be supplied and we will get lesser economy. So, this is how schematic diagram of a carburetor. Air filter is fitted on the top, then choke valve is open, at the below there is throttle valve is open. Now, the fuel and air is shown mixing and in the venturi and being supplied to the engine. So, this is a little modification in the simple carburetor. Here from this side here, this is the main body. We have already discussed this. This is the venturi and main jet which is supplying the fuel. But this one more circuit I have added over here. This is the idling circuit. This is called idling circuit. This pipe from here it comes down to here and it is just below the closed throttle valve area. So, now what happens during idling? Throttle valve is closed. This is throttle valve, this is open condition, and now here it has been closed. So, when suction will happen here, there will be no effect in this area, the air will not rush from here. So, but this area, this restricted area will be now vacuumized.